Okay, I'm going on with the next one. Can you see my screen now?
Not yet.
Okay, not yet. Okay, wait for a
Yeah.
while. Take some time to show my screen. Okay, can you see? Can you see my screen?
Not yet.
Not yet. Okay. When you can see, please let me know.
Yes.
Okay, you can see. Good. So the next thing is we're going to learn about telescope. We have learned microscope just now. We are going to learn telescope. And telescope also has two lenses. It has two lenses, but the difference is, okay, telescope. When we use a telescope, usually we try to look at close object or far object.
Far.
Far
Far.
object, good. If you try to look at far object, so you must apply the one which, okay, this one. You can see the object should be far away. In this case, object from infinity or from a distant object. You're going to apply this one. Okay, you're going to apply this one, and you are going to apply another one is going to apply which one? Okay, you're going to apply this one. Okay, you're going to apply this one, but the same thing you need to do is now you need to change the object should be downward like this. Okay, so let's try to draw it again for telescope. Okay, here is the lens. Now here is F, this is 2F, 2F, and then you have F. Okay, now light travels through F, straight line. Light travels through F, refracted parallel to principal axis. Now you have the object here. Right, this is our first case. And another one is object is on F, but we draw it downwards. Now light travels parallel to principal axis. Then it will be refracted towards F. And then you have another row. Light travels to the center of the lens. And then you cannot see any intersection because the lines here are parallel. So draw line backward, something like this. Okay, no intersection also. So let's try to combine this one and this one. Okay, you have a long straight line, the principal axis, and then you have objective lens. We call it objective lens is because object is on this side. Okay, this is FO because it's objective lens, and okay, we do it again. For this one, you need to make sure we have long focal point. So the focal length of the objective length is far, the distance is quite long from the lens. Okay, I draw it here. But for the microscope, we have learned just now, we use smaller focal length for the objective lens. But for telescope, the focal length needs to be longer, like what I'm showing you here. Okay, let us try to draw the object or the image. Now, light passes through the center of the lens. There is no refraction, so it goes straight on. And then another light parallel to the first light. Okay, that parallel, it will be refracted parallel to principal axis. Okay, try to make it parallel and make sure that the image is here. Okay, just like this one. Okay, that is image for objective lens. And then we are going to draw the second situation here. Now, you can see that the object is on F. So we must make sure that for eyepiece lens, we have F, E exactly on the same spot, because we need to apply this one. What you do is you adjust the telescope. When you adjust the telescope, you have the biggest magnification. So at that particular situation, FE and FO are exactly on the same spot. So now we have lines here, and this is FE. So we apply this one. Light travels parallel to principal axis. It will be refracted towards F, and line passes through the center of lens. There is no refraction, so light will the extension of the light backward like that, but it will never intersect because the lines are parallel. So how do you see the image? Because here is your eye. Here's your eye. Remember, your eye has retina, and it has also lens over here. It will be refracted to your retina, and then you can see the image. Okay, in this situation where the FE and FO exactly on the same spot, we call it normal adjustment. You need to remember this term. This is very important because it is always used in examination question. Normal adjustment. Normal adjustment means the the focal point of objective and eyepiece lens are exactly on the same spot. So in this case, magnification is maximum. So in this case, you can see the biggest magnification is in this case. That is what we call normal adjustment. So that is how we apply some cases from the 6 cases that we have done in drawing and in creating another devices such as microscope and telescope. And then something else I need to remind you, the distance between, okay, let me write here. This is eyepiece. This is eyepiece lens. Eyepiece lens. So the distance between eyepiece lens and objective lens is L. The distance between objective lens and eyepiece lens is L. This is L. Equals FO plus FE. You need to remember this. What is FO? Here is FO. This is FO. And here is FE. So in order to reach normal adjustment, we need to make sure that L equal FO plus FE. Okay. Now, do you have any question? Any question? Tell me now, please. Any question?
No.
No question. Is it so simple to understand this? Are you sure about this? You really understand? Do you think that this is easy for you? Because sometimes student comes to see me and then they ask me about this problem. It is as if it's too difficult for students. That's why I'm asking you again. If you have any question, you need to ask me now. Okay, do you have any other question, please? Tell me. Everything's okay? Are you still there? Hmm? Are you still there? Are you still
Yes.
there? Okay,
Yes.
good. Okay, one more thing I need to explain here is magnification. Magnification, the formula is FO over FE. This is important in calculation. Okay, please jot it down also. Okay, I think that's all for today. I'm going to give you the attendance form and you need to fill it um, so that I know that you have attended this online class. Okay.